everyone, it's Judy Warner. Welcome back to the Ecosystem Podcast. As you know, going into that dreaded EM chamber after you've designed a product can be really painful if you don't pass. And of course, it costs a ton of money. So I invited on my new friend, Juliano Mologni from Ansys. I've been following him on LinkedIn for a while and appreciate the things that he shares there, along with some super cool video graphics showing field emissions that are modeled through Ansys. I brought him on because he's just on the back end of an EMC SIPI conference, and I know he has a lot to share and will hopefully help you avoid some of those pitfalls. Thanks for joining us today. Now let's jump into our conversation with Giulio Mologni. Hi, Julian. Thanks so much for joining us today. I'm excited to share you with our audience and talk all about EMI, EMC today.
Yeah, thank you very much for the time, Judy. It's an honor to be here, and I appreciate the opportunity to explain a little bit what we do here at Ansys.
I've been sort of a cyber stalker in that you put up the coolest eye candy on LinkedIn, and I want to make sure and share with our audience because it's so great, the visualization that you give on LinkedIn. And, you know, for civilian non-engineers like me, it speaks volumes, and I think everybody loves it. And so I knew that I wanted to talk to you and get you on and talk more about that. And I know you also just came from an important EMC show, and so I also wanted to talk about that. So why don't you take a moment and tell us a little bit about you, your background, and what you do at Ansys.
Yeah, sure. So here at Ansys, I'm the lead electronics product manager. So I'm the product manager for some of our high-frequency electromagnetic products. It's basically the tools that companies and users, they use to design ICs, packets, print circuit boards, antennas, radars, anything that is related to electronics at a high frequency, megahertz, gigahertz, up to terahertz. Before I joined Ansys, I used to work for an Ansys channel partner in Brazil for 10 years, ESSS. Before that, I used to work for many different companies, Delphi Automotive Systems, designing wiring harness, print circuit boards, Motorola, where I was a IC package designer, and a few other ones. So it's been a very interesting adventure so far. I think the greatest advantage of being here at Ansys is that we have thousands of customers, over 40,000 customers. So I have the opportunity to work with companies on the high-tech side, on the automotive, aerospace. So I think it's a very good place where I am right now because I'm always talking to smart people like you and many of our people here in our audience, and I'm always seeing what's coming up next. What's going to be like 5G, 6G. Because people always seem late first before they design an actual physical prototype. So it's been a very interesting journey so far.
I totally resonate with that remark. I've said many times I get to work with some of the smartest people, and also I've had awesome field trips. So that's my two, and it's always changing, right? We're always pushing. So I find it really engaging and interesting. So I share that with you. So let's talk about, it seems to be a theme with my guests these days of shifting landscapes, right? Because higher speed, in your case, 5G, now they're starting to flirt with 6G, Internet of everything, right? And so much is changing so fast. And people are saying the old rules of thumb don't always carry forward really well. So what are you seeing in that high frequency space specifically about how engineers sort of keep up and keep moving with the technology?
Yeah, that's a very interesting question, and that's something that we're seeing, all across the industry. If you take a look at the simple products like, washing machine or even a light bulb, a light bulb is just a light bulb, right? But now they have Wi-Fi communication. Sometimes you have Zigbee, washing machine back, 20 years ago. It was just like an electromechanical timer and the motor, right? Now you have touchscreen display, you have antennas, you have wireless communication. And now, since you are adding that kind of electronic, because everything needs to be connected today, you have to go through a different set of EMC certifications, right? You have a product like a bulb, it's not too bad. But if you have a Wi-Fi antenna, then you have to go through lots of certifications, FCC, CE in Europe. And those engineers that were used to design a light bulb, now they have to know how to feed an antenna. And that's not something very trivial for most of the engineers who are only designing to, simple print circuit boards and things like this. Actually, I have a professor of mine. He gave me a very good advice. He was saying that there are only two kinds of engineers: the ones that are facing EMC and signal integrity problems, and the ones that are going to face, EMI problems and signal integrity. And he's absolutely right. I mean, I remember when I started in the simulation world 25 years ago, only high-tech companies were using simulation. But now we have everyone using our tools, an automotive industry, appliances, even the most simple IoT devices, they're using simulation because they want to understand what their products is going to behave like on EMC certification tests, but they also need to make sure that everything is going to work as planned, right? You have to match impedance for antennas. You need to make sure, your antenna is not interfering in digital signals and the other way around. So we're seeing more and more, more electronics everywhere. So I think that's the challenge that engineers are facing today. They just need to understand more about RF, EMC, signal integrity, power integrity.
Yeah, and I've said many times that because I had about a 5-year stint where I was focused on RF microwave PCBs and how really different they are, and there's things we could do, say that we're IPC compliant, but we'd still screw up the engineer, right? Because the way we lay down too much copper or the way we drill the vias or, whatever. And I just see this getting, in some ways, across the system worse and worse and worse because you have multiple antennas, right? And all these chances for interference. So what I've observed over the last 10 years is a bunch of engineers being drugged into RF, kicking and screaming, and then trying to catch up and understand. And they're doing a great job, by the way. It's because there are good companies and tools and educational resources that companies like Ansys provides. So I think that's really, really great. And millimeter wave, I know I've talked to a friend from Rogers, and he's like, rules of thumb at microwave are different than they are at millimeter wave. And so you don't want to get blindsided, which is why I want to have you on, right? So our audience goes, got it.
Yeah,
I need
absolutely.
to pay attention.
Yeah. Before I started with simulation, I was designing print circuit boards. And back at that time, you understand a few things like, current, resistance, inductance, capacitance. But when increasing the speed, it doesn't have to be like millimeter wave, 28 gigahertz. But if you're increasing the speed up to a few gigahertz, you need to understand like reflections, TDR, RF stuff. And that's, that's a big shift, moving from RLCs to S parameters, reflections, crosstalk, it's a big shift.
Yeah.
For the millimeter wave, for example, it's also very difficult to measure things at 28 gigahertz. One of the difference between 5G and 4G is that 5G millimeter wave, instead of having just a single antenna, you have an antenna array because you want to focus the energy on the users, right? So
Yes.
to do that kind of measurements at 28 gigahertz is very difficult. If you go to the FCC website, you see just search for a given product, you see that they have lots of measurements and even more simulations because they match a few measurements with simulation, but changing the radiation pattern of this antenna arrays and performing the measurements is very challenging. So simulation helps a lot on that, especially understanding electromagnetics. That's something that we don't see, right? Mechanical, you see something bending, right? But the electromagnetics is different, right? With simulation,
Right.
actually, you can actually visualize electric fields, magnetic fields, and that provides more insight. People understands better when they see, fields.
Yes. It helps me a lot by looking at your cool posts. I'm like,
Yeah.
it's one thing to conceptually think about a field, right? And
Yeah.
it's another thing to sort of visually see how it's emitting, right, off
Yes.
devices or boards or whatever. It's really cool. So a lot of engineers sort of balk against expensive simulation tools, but people keep telling me that you it's sort of no longer optional. Is that something, is that your perspective? And sort of, since you meet with so many engineers across the industry, what is your sense about when you get a pushback on the cost of owning really good simulation
Simulation
tools?
tools. Yeah, that's a question that we got, especially from small and medium business, right? I mean, simulation
Right.
tool, they can be very expensive, but we have many commercial options for that. But moving to the cloud, we have elastic license. You can lease like for a month or two. You can even request a service. We can provide technical service, so you don't need to learn simulation. We can do this work for you. But what we're seeing more and more is that
Oh,
adoption is increasing a lot, and the reason for that is because simulation, just like hardware, is expensive. But how expensive it is to a chamber and fail certification, how expensive it is to redo a prototype, not only the physical cost, but you're delaying your product, the launch of your product by weeks, maybe
yep.
months. How expensive is that? Because your
Right.
competitors, they're launching on time, right? If you take a look at cell phones, cars in the past, a car, you had a new model year. Every 5 years, you have a new model, right? Today, every year you have a new model. And how do you think they're doing this? Just simulation. Without
Yeah.
simulation, there's no way you can actually decrease the, development cycle, in order to, keep launching products, more often.
Just being the devil's advocate here, if someone, say, works for a small company, say someone in our audience works for a really small company where they just don't have the spend at this point, or maybe they're a startup, right? What would you recommend? I know there's some maybe open source or low end tools, and I know they don't have the functionality of a tool like Ansys, but let's say that I'm a startup. What would you recommend as an expert in this industry?
Well, I'll recommend to get in touch with the Ansys startup program. We do have a startup program where
Okay.
we love companies, we love startups, we love to help them. I mean, there are many free tools, but in the end, it's not only a tool. I mean, you're only going to get benefit if someone helps you to use the tool, right? And that's what we do
Right.
here. We're not only providing you a tool, like we're also teaching you how to use it, how to get benefit from that. So I think that's the biggest difference. There are free tools on the market for everything, but if they're not going to provide you support. They're not going to teach you how to use it, right? You're going to have to figure that out by
Right.
yourself. It's going to take some time. So, we do have this startup program where, we help all the, hundreds, thousands of startup companies, I think, and we help them. And when they grow, we become even more partners. We tighten the partnership and we help them grow even more. And having Ansys, just like many of all of these companies, as a partnership for a startup, is also very good because they're trying to get money, customers, ideas. And having
Right.
someone like Ansys, you were just mentioning Keysight, all of these companies backing them up is also really good for them. So that's the reason we have this startup program.
I know, and it can't. I really didn't cue you up to give an Ansys commercial, but I know that's your sincere answer. And having worked at Altium, and we had a university program, I would tell students the same thing. Like when you get a job, rather than Eagle, on your resume, to say that you know how to use a professional tool actually helps you on your career path, and it helps you as a company to have better results. And so, I didn't mean for us to sound like but I do resonate sincerely with that, having worked for another company with a similar tool, and understanding that, using AutoCAD, Eagle, or one of the either KiCad, open source or whatever, is great. It'll help you get your senior capstone project done, or if you're a startup, it'll get you off the ground, but then what? So I really do resonate with what you're saying. And a lot of people don't know that companies like Ansys, Altium, Keysight, whoever it is, a lot of these companies do have programs for startups and students, right? Which help, again, it just helps the
Yeah.
whole industry.
We
Yeah.
have
Okay.
academic for universities, and also anyone can download our high frequency electromagnetic tools. Any student can actually download that for free with a single click. We provide that as well. But unfortunately, we don't provide support for all the students around the world. But
Yeah.
there's an
Yeah.
Ansys forum where, from time to time, some of us, we go there and we answer some of the questions.
Right. And I imagine Ansys also has some online resources. I didn't look into that ahead of
Yes,
time. I should have
a
asked you.
lot.
Okay.
Yeah. Right.
Yeah. Okay. So they can self-educate and support as much as possible. We've talked about this idea of when it comes to EMC, whack-a-mole, right? You solve one
Yeah.
problem and you create another. Can you talk a little bit about, what that might look like in the context of EMC?
Yes, absolutely. I mean, I've been in the EMC world for several decades now, and we have seen a lot of different and even curious things. One of the things that we see a lot, and I mean a lot, is that, in many different companies, you have someone who's designing a PCB, and then you have an engineer who's responsible for the thermal behavior. So, if you have to place a heat sink or a cooler, nobody wants to place a cooler because it's very expensive. A heat sink can, increase the weight. And then you have EMC
Right.
engineers that, they're evaluating the board and they have to go to certification. So one thing that we see a lot is that someone designs a PCB and then there's a thermal problem, right? The PCB is okay. I mean, if you take a look at the electromagnetic compatibility, but there's a thermal problem. And then the engineers say, hey, okay, I'm going to put like a heat sink in here. When they add a heat sink to the print circuit board, you're creating an electromagnetic problem. So you're solving a thermal, but you're
Yeah.
creating an EMI problem. And then the other engineer goes, now we're testing this and it's failing. So you have to remove this. So it's kind of like you're fixing the thermal problem, but then you're creating an EMI problem. Same thing happens with connectors, with capacitors. I've seen companies that, they were trying to reduce the cost of the product, cost reduction programs, they're everywhere, right? So they were just like removing a few this was a radio, a product, right? So they were removing a few components like chokes, and they, instead of redoing all the certification tests, they just did the check on the audio quality. So the quality of the sound was still good, and they remove a component, they multiplied that component value of like $1 for millions. Hey, I'm gonna save millions. The problem is that component was a choke, was actually, in there to suppress conducted noise. So what happened is that some of the customers later, were seeing, odd things, right? Because when they were increasing the volume of that radio, things were starting to, behave very oddly around it. So, customers went back there and they say, yeah, we had this problem. So, we're trying to save costs, but, in the end was a problem. So those kind of things, someone's changing your product and not doing all the tests or creating different problems. We see that, all the time, especially when you have multiple physics, right? Mechanical, thermal, electromagnetics.
Yeah.
They're usually different engineers, so they don't know what's going to affect, the change that they're doing to the product, what's that's going to affect on EMC or thermal or mechanical.
So there's been a lot of talk about sort of a system-based thinking, right? And
Yes.
being aware of your corollary stakeholders, which can be challenging. And we've talked forever about these silos. So, what practical advice can you give engineers to sort of think about all those things instead of throwing their one piece over the wall and creating another problem and all this back and forth? Like, what about reliability over time? Like,
Yeah. And as you're saying, it's a system, like, it's part of a company. If you ask an engineer to learn electromagnetics, thermal, mechanical, I mean, it's very challenging, right? So what we are seeing more and more is actually, companies creating automated workflows. So, if you're making a change to your product, you have to rerun those tests, right? It doesn't have to be simulation. It could be a physical test, right? But the simulation, it's easier because you can upload your changes, to somewhere on the internet of a company, and, you can run simulations in the background in an automated way and get a report
Right.
like, hey, the change that you did does not affect EMC, for example, right? So that's something that we're seeing more and more, because EMC certification is just the first step, right? You can pass EMC, but you can still have a problem in the field, right? I mean, those are things that we see more usually on automotive. You see those recalls. Nobody wants to see that. I mean, those are certified products,
Right.
but they are failing in the
Yeah.
field. So as you're saying, one of the things that, we have is something that we call product, reliability. So, you have a print circuit board, you have the thermal profile, you have the electromagnetic profile, and then, the currents are going up and down all the time. You have, high speed current switching, very fast. And that's along the years is going to create problems, thermal stresses, fatigue. And that's something that we can actually compute, the mean time between failures. With this thermal profile, in this behavior, you're going to place this, let's say, in a car that's going to drive, 100 miles per day on a bumpy road. This is going to last like 6 years, or this is going to last like 5 years.
I see.
Yeah. So this is different from certification, right? Certification is one thing. The other thing you need to know is, how long my product is going to last, in a given environment. It could be in an airplane, in an automobile, you don't know. So, predict the environment where your product is going to operate. It really helps.
It must be challenging when, say, with the automotive, and I know automotive standards are really rough, and so to still see, it's sort of like the corollary to what I was saying about PCB is they can comply to everything IPC says, but then depending on the environment or, whatever, you don't have the whole picture. And so, in case of automotive, you might live in Minnesota or you might live in Arizona, right? It could be under extreme heat or extreme cold or salt on the road, and same with airplanes going, flying from Arizona, going into high altitudes and moisture and, all these things. So, again, when I say all that, Juliano, it sounds like, forget it, I just want to go home, right? But engineers are so clever. So how, in your mind, do you have any advice as far as how to sort of onboard? Like, in other words, if you're designing a part or a system, you're responsible for thermal. Like, how can the person that's doing the thermal modeling think about the next engineer in line, or the mechanical, or, how can we gain this more system-based approach? Do you think these automated workflows are, EDA tools basically is what you're saying, and cloud enabled, right? So is that the best kind of outlook you see for engineers?
Well, not for engineers, but for a company. I think for engineers, it's really important for them to be up to date, with the experts in the field and what's happening, So, for example, I just came back from the IEEE EMC SIPI conference in Grand Rapids, where, I can meet the most, amazing and most smart guys in the field, for EMC and SIPI. When we go to DesignCon, when you go to APAC, for power electronics, that I think, if I'm an engineer, I want to know what's happening out there, what's, I need to learn. I think, creating this, being part of this network, watching your podcasts, right? See the publications in LinkedIn from all the experts that we have out there. I think that's the first step, right? I mean, you of course have to have the, your background, your theory, you need to understand,
Right.
electromagnetics or thermal, Maxwell's equations, Navier-Stokes. But then after you have this background, you need to know what's happening out there, what's going on, right? And talking to the experts in the field, watching your podcast, going to conference, I think that's the best way to do this, to learn insight, to learn what's happening out there.
Yeah, well, that's certainly what I'm aspiring to do here, and why I call it the ecosystem, right? Is getting all different experts like you on to give more awareness to engineers so they can have that. I think it's, for me, at least how I imagine it, unless you think otherwise, it seems like a situational awareness, and also the landscape's always changing, right? So you have to self-educate all the time.
All the time. An ecosystem is something that we take very seriously. We have integrations within Keysight, Pathwave, ADS, or F-Pro. You can run our tools from there. We have integration with Altium. We have the same thing with Autodesk and Zuken, because we understand that there are tools everywhere and people are using many different tools, right? So, having this open ecosystems, with Synopsys and all of the tools, it's very important. Just like what you're saying here, you're creating an ecosystem, right? And that's what we have to do. We take this very seriously here at Ansys.
Well, I really admire Ansys for that particular reason, right? I think the days of us as companies, actually, that serve engineers staying in a closed loop, right? I think that as we allow for that integration across multiple tools, I think everybody wins, but specifically engineers win, right? And the world kind of wins, because hopefully it gets done right. And so, yeah. Well, this has been a fantastic conversation. Thanks so much. And I hope you had a great time at the EMC SIPI conference. I was sort of watching from the sidelines, but it looked like a terrific show. Where would you like our folks to go learn more about Ansys, maybe some of your educational resources, your forum, and how can they plug in and become part of the Ansys ecosystem?
Yeah, that's a very good question. If you're an Ansys student, you can just Google Ansys student, and you're gonna find our forums, where you can download our tools. If you just want to learn more about electromagnetics, you can go to Ansys Electronics. We have a web page. If you have questions and if you have requests, like rule of thumb, like 3W for crosstalk, I want to see why this is not working anymore, just ask me on LinkedIn. I'm going to create an animation and explain that to you. So I'm always open, to talk to everyone. And I really appreciate this opportunity, Judy. I had a great time in here. It's always great to talk to you. And hopefully, we can meet again soon.
Yes, I hope so. Well, I'm definitely going to nab you, because actually send me a couple of those of your favorite animations, and I'll try to integrate them into the video part of this. So our listeners or people that are watching on YouTube can see how cool they are. And I'll definitely put your LinkedIn profile before. So Juliano, thank you so much for all that you do for the industry, as well as Ansys. I appreciate your time today, and I hope to have you back again soon.
Yeah, sounds great, Judy. Thank you very much. Yeah, talk to you soon.
Okay. For our listeners, please go check out. After Juliano and I finish here, I'm going to go nab all those links from him and give you a bunch of stuff to plug into. And please come and join our community as well. And we're going to do our very best to keep you up to speed and equipped while you're out there doing all your great engineering work. Thanks for joining us today. We'll see you next week. Until then, remember to always stay connected to the ecosystem.